So in this video we're going to review how to divide complex numbers. And in order to divide complex numbers, we need to first discuss the idea of a conjugate, or in this case a complex conjugate. And all a conjugate of a complex number is, you take the complex number that you start with, you look at the operator that separates the real part from the complex part, the part that has the I, and you replace that operator with the opposite operator. So if it's plus, you're just going to replace it with a minus. So the complex conjugate of a plus bi is the complex number a minus bi. So here I have 2 plus pi I have a complex number. Here's the real part, here's the complex part. It's separated with a plus, so the conjugate is just going to be 2 minus pi I. Real part, complex part, replace the operator that separates the real from the complex part to get the complex conjugate. We got the real part, the complex part, change the operator that separates them, so 4 plus 6i, and now I have the complex conjugate. The real part, the complex part, subtraction is the operator in between the real and the complex part, change that operator, and I have the complex conjugate. And the reason the complex conjugate is going to be important to us is if we multiply a complex number by its conjugate. So here I have the complex number 4 minus 6 times I. If I multiply a complex number by its conjugate, so here I have a real part, complex part, subtraction is the operator separating them, so replace subtraction with addition. When we multiply a number by its complex conjugate, what we'll see is that we wind up with a real number. The complex part goes away for us. And we're going to need to eliminate a complex number from a denominator when we do complex number division. So if I look at multiplying this, I get 4 times 4 is 16. Distributive property, 4 times 4, 4 times plus 6i, so 4 times 6 is 24i. So plus 24i, and then minus 6i times 4 is minus 24i, and then minus 6i times plus 6i is going to be minus 36i squared. So I get 16, and notice that the middle piece cancels. 24i minus 24i is 0i. Those two pieces cancel, and I'm left with just what's here. So minus 36 times I squared, but remember I squared, or I times I, is just equal to negative 1. So we can replace I squared with negative 1, and we wind up getting 16 plus 36, which is what, 52? So notice there's no I in the thing that's left. It's just a real number. So this is going to be a tool that we use when we do complex number division. So here I have a division of complex numbers. I have a complex number in the numerator, a complex number in the denominator. And essentially what you need to do complex number division is eliminate the complex number from the denominator. And to eliminate the complex number from the denominator, we're going to multiply the denominator by its conjugate. So I have a real number part, complex part, the operator between them is minus. I'm going to change that minus to plus. So we're going to multiply the denominator by its conjugate so that we have a denominator that doesn't have a complex number in it. The idea is we're trying to get a number that's in standard form, a plus bi, and the I part should be in the numerator position. Well, I can't just arbitrarily multiply a denominator by something without changing it. So it's the same as if you're adding, let's say, a half plus 2/3. What would you need to do to get your common denominator of 6? Well, you'd have to multiply by 3 over 3 and 2 over 2. You have to multiply by a 1. So that you don't change the value of the number. You rewrite it in an equivalent form by multiplying by 1. So we're going to take advantage of that same concept here. I'm going to say, hey, I want to get rid of the complex number in the denominator. So all I need to do is multiply by the conjugate. But I can't just randomly multiply the denominator by a conjugate, so I'm going to multiply the numerator by the same thing so that this ratio is really equal to 1. 4 plus 2i divided by 4 plus 2i is 1. And now I work out the division. I get 3 times 4 is 12. Distributive property, 3 times 2i is 6i. And so I've multiplied 3 times everything over here. Now I'm going to multiply minus 7i times everything in here. So I get minus 7i times 4 is minus 28i. And minus 7i times 2i is minus 14 from the minus 7 times 2. And then I times I is just I squared. And this is all over. 4 times 4 is 16. 4 times plus 2i is plus 8i. Now I move to the minus 2i. Minus 2i times 4 is minus 8i. And minus 2i times plus 2i is minus 4. 2 times 2 is 4. And then I times I gives me I squared. And notice how, just like on the previous slide, the stuff in the middle canceled because we multiplied by the conjugate. So that stuff is going to go away. And we can start to do some simplifying. So the numerator, I get my 12. 6i minus 28i is going to be minus 22i. And I have minus 14 times I squared. But I squared, remember, is just negative 1. So I can make a replacement there. In the denominator, I have my 16. The I terms canceled. So I have minus 4 times I squared, but I squared is just negative 1. So now I have no complex number in the denominator. I keep simplifying, so I get 12 minus and minus makes plus, so I get 12 plus 14 minus the 22i that I already had, and it's all over 16 plus 4 is 20. So I'm going to go ahead and bring this up over here. I've got the 12 plus 14 is 26 minus the 22i, and this is all over 20. And now to get it into standard form, I need to break this into the two fractions. One fraction will have just the real number part, plus now I'm going to have a fraction that has the complex part, so I have my negative 22 over 20 from right here, times I, where I is right up at the midpoint. The midpoint of the I should be at the fraction bar. I shouldn't write the I so it looks like it's down in the denominator. So my I goes here, and then I just simplify the two fractions. So 2 will go into both of these numbers. This will simplify to 13 tenths. Plus 2 will go into each of these, so negative 11 tenths I. And now I have my final result, a complex number in standard form.